Back to Genesis, a series of programs for the entire family featuring many of the world's leading creationist speakers. They will answer your questions about creation and evolution and will demonstrate that the book of Genesis is reliable and vitally important.
Can you just start with the laws of chemistry and physics and get life? Now, this is a topic that's very, very important. It's important to both the creationist, it's important to the Christian, it's important to the evolutionist, it's important to a lot of different people. This whole idea of whether or not the origin of life is just a matter of chemistry is absolutely essential. It's absolutely vital for everyone involved. And what we're talking about is abiogenesis. Can life come from non-life? This is something that's very, very important that we look at. And right at the start, I want to say this. I'm going to try not to get too technical. Some of the parts of what I do will be a little technical, but I'm going to try to give everybody something they can hang on to. If you want something a little bit technical, I'll have it. If you want some broad concepts, I'm going to give you 3 broad concepts to look at. And this is what I really would like to see you get out of it. Okay. Abiogenesis, life from non-life. Is life just chemistry? Who cares? Y'all must. Y'all came to listen to me. Evolutionists care about it. I think high school and college students should care very much. Whether they go to public school or Christian school, it's very, very important for them to look at this issue. And I'm going to show you why in just a second. And finally, I think it's very, very important to Christians. Abiogenesis. Why is it important to the evolutionist? Did you realize that abiogenesis is absolutely essential to the evolutionary belief? The evolutionist has to get life from non-life. You see, what the evolutionist says, and even Darwin understood this, is that if man came from an ape, and if that ape came from a simpler animal, and that simpler animal came from a one-celled animal, and that one-celled animal came from the first one-celled animal, where did the first one-celled animal come from? You see, you can keep going further and further and further back, but eventually you go back so far that you just can't go back anymore. You reach that boundary between life and non-life. And in order to get life from non-life, you have to be able to take just chemicals acting under the laws of chemistry and physics and allow them to come together in order to form life. From man to ape to one-celled animal to the first one-celled animal, right there at that boundary, you've got to be able to cross it. You've got to have chemicals come together just with the natural laws of chemistry and physics, with no help from the audience, please. Or else, if you can't get life from non-life by the laws of chemistry and physics, somebody has to step in and arrange those chemicals. The minute that happens, that somebody is God. You've just put intelligence into the system. You no longer have abiogenesis, and more importantly, you no longer have evolution. Once God enters the picture, it's not evolution. The evolutionist absolutely must have as his whole foundation the concept of life from non-life just by the natural laws of chemistry and physics. Please remember this. It's foundational. It's the starting point. If he cannot get out of the starting blocks by having the natural laws of chemistry and physics produce life from non-living chemicals, then we don't even have to discuss the fossil record or what he thinks it shows. There's no way that he can ever get evolution. He has to appeal to an intelligent source to start life if this isn't true. Why is it important to high schools and colleges? Well, it's being taught as a fact, or it's at least being suggested as a fact in many high schools and colleges. If you have a high school or college kid, and he's going to school, she's going to school, they're going to be taught that this idea of life from non-life, if it at least hasn't been produced, it's this close from being produced. And they print things in textbooks that simply are not true, or at best are simply misleading. One of the biology textbooks that's used in Orleans Parish schools. Let me show you what they wrote in it. The idea that an organic soup could originate from a primitive atmosphere was tested in the laboratory by Stanley Miller in 1953. This demonstrated that complex organic molecules could have been produced from inorganic ones. Well, what is a complex organic molecule? They're calling it a protein. They're calling it an amino acid. In fact, they specify 2 amino acids, glycine and alanine. Some people would argue whether or not that's a complex organic molecule. Yes, it is an organic molecule, but how complex? And what they don't tell you is that the alanine and glycine that were produced were the wrong type. That's intentionally misleading because they know better. And they know that that experiment could never lead to an origin of life. If you turn the page, they make another statement that I find highly questionable. These primitive cells could have flourished at first. Goodness, they've gone from 2 amino acids all the way up to a cell. They've not only gotten proteins, they've gotten DNA, they've gotten a cell membrane. They've gotten to a complex structure. And you see this statement that these primitive cells would have flourished? That's blatantly false. That's a lie. And I'm going to proceed over the next few minutes to show you that that never could have happened, that they could never have flourished. But that's what's being printed in the textbooks. That's what's being taught. Another biology textbooks that's used in Orleans Parish schools. Open it up, and you read this. The mild heating produced large molecules that resembled the proteins of modern organisms. That's blatantly false. They got amino acids to hook together, but they bore no resemblance to the very complex, very differently arranged proteins that we see in organisms. Furthermore, many of these things that were produced in this experiment by a gentleman by the name of Fox contained amino acids that were not like the amino acids that we find in proteins in living systems. It was a mixture of left and right-handed amino acids. And that will never work in living systems. You never find that. The next sentence says, these proteins were highly ordered and had enzyme activity. They were highly ordered in that they were basically made up of only 1 or 2 types of amino acids, just a few amino acids. They were ordered, but they weren't complex. And that's the problem. Ordered proteins is not what you see in living systems. So if these were ordered, they have nothing to do with living proteins, or proteins that we find in living systems. If they were ordered, they have nothing to do with the origin of life. And it's this type of misleading statement that makes this whole idea of abiogenesis, life from non-life, very important to anyone who's getting an education. And this applies to both Christian and public schools. Just because you go to a Christian college doesn't mean that you're going to have good scientific creationism presented. It's very, very important that you realize that. Finally, it's important to us Christians because it contradicts Scripture. You know, abiogenesis says that life comes from chemistry. Life comes from the laws of chemistry and physics, acting over billions and billions of years, or at least millions of years. But what do the Scriptures say? The Scriptures say that God formed man, that God gives life to man. The Scriptures say, with thee is the fountain of life. When I read the Bible tells me that the origin of life is not with chemistry, that you're not made in the image of a molecule, that you're made in the image of God. Not only does it contradict the Bible, it contradicts the words of Jesus himself. Jesus said, for the bread of God is he which cometh down from heaven and giveth life unto the world. I am the bread of life. Jesus claimed that he was the source of life, that he was the source of eternal life. If abiogenesis is true, if the laws of chemistry and physics are the source of life, then Jesus is lying. No way to compromise that. No way to whitewash over it. Jesus either told the truth or he lied. Finally, the gospel itself deals with life. The wages of sin is death, the gift of God. You notice it says the gift of God, it doesn't say the gift of a medical institution or a medical research laboratory. You notice it doesn't say that the gift of the biochemist or the gift of chemistry or the gift of chemical reactions. It says the gift of God is eternal life. Where does eternal life come from? It's a gift of God. This is the record that God hath given to us eternal life, and this life is in his Son. Jesus' own words, the Bible itself, and the gospel all, I would say, directly relate to this whole concept of abiogenesis. Is it important? Absolutely. If abiogenesis really occurred, then Christians, we need to step back and reconsider what we're saying. And even though this gets a little technical, and I'm going to try to make it as non-technical as possible, it has tremendous implications for us because it reflects upon the words of the Lord, the gospel itself, and the Bible as a whole. Now, let me give you the answer. Let me give you the summary before I get started. Have any laboratory experiments where you begin with just chemicals and just allow the laws of chemistry and physics to work, have any chemical experiments been done in which they've produced life in a laboratory? I get a lot of people that come up to me and say, Dr. Girouard, these scientists have produced life in a laboratory. Has any experiment ever been done which has achieved that? And the answer is no. All they get are dead-end products, wild exaggerations, and smelly lab coats. And if you ever worked in an organic lab, you know smelly lab coats is true. No one's ever produced life in a laboratory. No one's even come close to it. And we're going to look at that evidence in just a while so that you can see that no one is even near achieving this. Don't be fooled. Just because somebody says something doesn't mean that it's true. Do the laws of chemistry and physics allow for life? Is it at least possible? Is it probable or even possible for the laws of chemistry and physics to produce life in a laboratory? And again, we'll look at those laws. The answer is no. The principle of the second law of thermodynamics says that things do not get more organized. Things fall apart. They run down. They wear out. Things become less organized. Things lose information. Just like we talked about the Xerox machine. If you take a copy of a copy, and then copy that copy, and then copy that copy, you lose information. It becomes more blurred. It doesn't turn into a four-color print. And that's exactly how the second law of thermodynamics applies to information theory. The second law of thermodynamics, as it applies to information theory, basically says this. Information can be transferred, but it can't be created from nothing. Or, put it another way, you can't get what you ain't got. In other words, that if I start with molecules that have no information, I'm not going to get those molecules with no information to come together and form an information system. Think of a Scrabble board. You've got a Scrabble board, and you've got all of these little wooden pieces with letters on them. Do they self-assemble themselves? No. Is the information in the ink or in the wood? Or is the information in the arrangement of those little wooden pieces? When you look at a book, is the information in the ink, the paper, or in the arrangement of the letters? You see, the information is not even in the letters. It's in that arrangement. And when we start looking at living systems, when we start looking at the DNA and the proteins in living systems, that's exactly what we find. That the information is not in the chemicals. The information that makes these systems is found in the arrangement that we put the chemicals. And the second law of thermodynamics tells us that you can never get those chemicals to arrange themselves to have information, that you have to put information into the system. The laws of chemistry and physics, moreover, will show us that those chemicals would never come together in the arrangement that we find them in biological molecules. This is what we want to look at. Okay. That's the principle I want you to get at. If you understand that, then you understand a lot of what we're going to say. You understand basically all that you need from this. Now let me get a little bit more detailed. Everything I'm saying comes from this book, The Mystery of Life's Origin. I was going to bring some copies, but we sold every one that we had. If you see this book and you want some more technical information, this is a little technical. Doctors Bradley, Olson, Thaxton have written this book. They've done an outstanding job with it. If you know some college chemistry, you'll love this book. You need to know a little bit P-Chem, a little bit physical chemistry, but not a whole lot. But this is an outstanding book. Even if you knew no chemistry, you'd still understand about 30% of the book. You'd understand the main concept when it deals with information. But this is where most of my lecture is going to come from. It's an outstanding book. Now, let's make life. Making life in the laboratory is easy. All you need are the right materials under the right conditions to get the right products of the right kind in the right amount, to have the right reactions at the right location in the right sequence with the right information to build the right structure to do the right functions that make life. It's easy. I can't believe they haven't done this before. Now, that's the easy part. Let me show you what's hard. You've got to have every one of those 11 steps occur. If you're missing any one ingredient, the whole machine breaks down and you won't get life. Nothing will work unless you've got every one of those 11 steps in order, working in the right place, and functioning. If you lose one step in the chain, then the whole thing's going to break down. As Noah tells the animals, well, so much for the unicorns, but from now on, all carnivores will be confined to C deck. You've got to have an unending chain of all 11 processes, because if any one of these along the chain breaks down, we can end the discussion and go get something to eat early. Every one of these has to be true. Let's take a look at them. Scientists have been trying to do this now for some years. One of the first men to attempt it was a gentleman by the name of Stanley Miller. Back in the 1950s, he set up an apparatus. And what Stanley Miller did was that he took a flask with these chemicals, methane, ammonia, water vapor, and hydrogen. He heated his flask, bubbled out these chemicals. He had them pass over an electric charge to simulate lightning. Then he cooled them. He collected them in a trap. He collected whatever product he made in a trap, and this just kept going round and round. But the important thing to remember here is this, that whatever he produced, he collected and isolated in a trap. He kept it away from going back into this flask, which was being heated. That's going to be a real important point. We're going to come back to that, okay? But doing this, he said, let me see if I can make some building blocks that go to forming life. And what he was trying to make was this. He was trying to make amino acids. If you don't have amino acids, you can't make proteins. Amino acids are strung together like the pearls, like a string of pearls. The amino acids hook together to form proteins. If you don't have proteins, you don't have life. And if you can't get amino acids to form the proteins to form the life, you can't get evolution. To form DNA, you need bases, sugars, and phosphate. You need three things to form DNA. And again, if you don't have DNA, you don't have life. So these were the building blocks he was trying to make. And in this particular experiment, what he was shooting for were amino acids. And what he did was very interesting, because a lot of times people just completely ignore his starting point, the fact that he started with those gases. He and a lot of the evolutionary scientists believed that the materials that he had to start with not only included these, but also things like formaldehyde and hydrogen cyanide. If you don't include formaldehyde, you know that smelly stuff if you were ever in a biology lab that you dunk frogs in to make them smell bad so that you can't eat lunch? You ever did that? If you don't have formaldehyde and hydrogen cyanide, you just don't form any sugars. So this is absolutely important, because you need sugars to make DNA, to make life. And if you can't make that life, there's no evolution. And if there's no evolution, then you need God. So these are all the things that you need, but he decided to just confine himself to the methane, ammonia, water vapor, and hydrogen. Now, he believes that all of these chemicals existed in the primitive atmosphere. He goes back billions of years, and he says billions of years ago, that's what was in the atmosphere. Why? Why does he pick those chemicals? Why does he pick those chemicals? Because those are the chemicals that would produce the product he was trying to make. If he starts with these chemicals, he's sure that he's going to get some amino acids. That's cheating. That's like being on Jeopardy. They give you the answer and you work backwards to the question. He knew exactly what he had to start with to get the answer he was looking for, so he did that. Now, you know, a lot of times Christians and creationists are criticized by evolutionists because they say, oh, you start with the Bible, you start with answers. What about Stanley Miller? He started with answers. He fixed the experiment to where he couldn't fail. And that's exactly what he did. He picked the elements he knew would give him what he wanted. Well, let me ask you this. Maybe I'm being a little hard on him. So the important question to ask is this. Is there any evidence that billions of years ago you did have these elements in the atmosphere? If this is what they think was in the primitive atmosphere, is there any evidence that billions of years ago you did have an atmosphere that existed like that? Because if there's no evidence for it, all we're doing is guessing. We're just speculating, right? There's absolutely no evidence whatsoever of an ammonia, methane, hydrogen type of reducing atmosphere. There's no rocks that have ever been found that shows that this is the type of atmosphere that ever existed. Now, I'll be the first person to admit that just because there's no evidence of it doesn't mean that it didn't exist. But let me say this. It doesn't suggest that it was there either. Lack of evidence is the wrong way to start when you're trying to determine what occurred in the past. Most of the time, you look for positive evidence, and the evidence just isn't there. Could you have gotten the right materials? It's questionable. There's no evidence that the right materials ever existed, but I tell you what, I'm such a nice guy, I'm going to go ahead and give the evolutionist this. I'm going to say, well, possibly he could have gotten the right materials, but could he have gotten the right conditions? You see, just because you get the right materials doesn't mean that you have the right conditions. Once you get your chemicals and you're trying to build your building blocks, you've got to be able to keep them. Anybody that's been fishing knows that's true. Just because you got it doesn't mean that you can keep it. If there's any fishermen out there, you're probably like me. Biggest fish I ever caught got away. You've got to be able to preserve those chemicals if you get them. If you're going to make amino acids, you have to be able to preserve them. By golly, you've got to be able to preserve your methane, ammonia, carbon dioxide in your atmosphere, the things that you're trying to get to react. Well, there's a problem. Most evolutionists believe that the sun has been around at least as long as the Earth. Okay? And what they don't take into account is the problem of ultraviolet radiation coming from the sun. You see, if there's ultraviolet radiation coming from the sun, those ultraviolet rays would destroy methane. In fact, it would completely polymerize the methane. It would react with itself and form an oil slick on top of the oceans 10 meters thick. That's about 33 feet thick. There goes the methane. Without methane, you can't make any organic molecules. You'd destroy almost all of your formaldehyde, all of your carbon dioxide. You disassociate all of your ammonia. But most importantly is the last thing. Catch this one. If you did have a sun, which they say was there, and you did have ultraviolet radiations, you would destroy any living organism that was on planet Earth. Well, now, wait a minute, Dr. Girouard. That's pretty ridiculous, isn't it? I mean, the sun's out today. We've all been outside, and we're still alive, right? Why? How come the ultraviolet radiation from the sun doesn't kill us? Because we've got something magical in our atmosphere. We've got oxygen. And with 21% oxygen in the atmosphere, we form an ozone layer which acts to shield out the harmful ultraviolet radiation from the sun, or most of it. And the reason why living things can stay alive in spite of the sun's ultraviolet radiation is because of the oxygen. Well, there's the answer to the evolutionists' problem, right? Just add oxygen to the primitive Earth. Just say that billions of years ago there was oxygen. No. Thank you for playing anyway. Oxygen isn't the solution, oxygen's the problem. You see, oxygen stops the chemical reactions that would take place to form bases, amino acids, and sugars. Oxygen would prevent those reactions from occurring. Furthermore, all of these chemicals, all of the building blocks are rapidly oxidized. They're burned up by oxygen. So that if I did have ozone in the primitive Earth's atmosphere, it would quickly destroy any of my chemicals long before I'd go down those 11 steps to get to life. Oxygen's not the solution. Oxygen's what? It's the problem. And I guess you could express it like this. You need oxygen to protect your products. But the minute you put oxygen into the experiment or into the primitive Earth, it destroys the products. So you never get anything. You need it, but as soon as you get it, it destroys what you have. Notice what gas is missing in Dr. Miller's experiment? See why he left the oxygen out? Thaxton, Bradley, and Olson in their book express it this way: since living organisms and organic molecules need the protection from ultraviolet radiation provided by an ozone screen, yet the presence of oxygen prevents the development of such living systems and biological molecules, this would seem to constitute a catch-22 in the model. Scientists have known that for a long time. In fact, it's not only the creation scientists who know that, even the evolutionary scientists know that. Recognize this name? Listen to what Dr. Sagan said back in 1966. As soon as the net laboratory conditions become oxidizing, the organic syntheses effectively turn off. This is a well-recognized problem. Well, Dr. Girouard, what's the evidence for the early Earth's atmosphere? Is there any evidence that oxygen existed in the early Earth's atmosphere? Oxygen has been found in sedimentary rocks that the evolutionist would date as old as 3.4 billion years old. I don't believe in the old ages, but the evolutionary geologist tells us that there is evidence that oxygen has always existed in the Earth's atmosphere. In fact, there's a group of evolutionary scientists who say that there is no evidence any time of an oxygen-free atmosphere. Oxygen has always existed. If oxygen has always existed, could you have gotten those products to react to start on the chain to form life? What's the answer? No. Impossible. Oxygen would have destroyed it. And you know what? We said that once we reach a point where we can't go any further, it's what? It's the end. But I'm going to be complete. Let me keep going down that line. We don't know if we have the right materials. We definitely have the wrong conditions. Can we get the right products? What's the products that we're trying to form? Amino acids, bases, sugars, and phosphate. Those are the things that we need to get in order to form, the products of life. In order to make proteins, we need amino acids. In order to make DNA, we need bases, sugars, and phosphates. Those are the three, and I'll just show you real quick what they look like. This is the basic structure of an amino acid. We substitute at this place right here different chemicals, different atoms to make a different type of amino acid. And with the bases, we've got 4 different types of bases. Those 4 different types of bases and the 20 different types of amino acids work like a code, works like an alphabet. That's the best way to think of it. 4 different bases, like 4 letters in an alphabet, 20 different amino acids, like 20 different letters in an alphabet. These are the 2 bases, types of bases, purines and pyrimidines, and we need one particular sugar. We need deoxyribose. That's what forms DNA. And of course, we need phosphate. So the things that we're trying to get, this is what's important. We're trying to get these things: amino acids, bases, phosphates, and sugars. We need to get those to get the right products. Is that what we get? The answer is no. We get a problem with these 3 things. Remember we said formaldehyde was absolutely essential to get sugars? Well, if you have amino acids and bases in the presence of formaldehydes, they react. The carbonyl group reacts with the amino group, and you get an amine. Let me translate that for everybody who didn't have biochem. You get a dead-end product. That will never lead to life. Formaldehyde destroys the amino acids and the bases. If you're in the primitive ocean, like the evolutionist says, you've got calcium and magnesium floating around in that ocean. It reacts with phosphate. It precipitates the phosphate out, it forms rocks, and guess what? You never get any phosphate in the ocean. Thaxton, Bradley, and Olson say that you could never get any soluble phosphate in the ocean. Nobody even has an idea how it could be overcome. You get dead-end products. Do you get the right products? No. You get nothing, but it gets even worse. Could you get the right kinds of products? This is the unsolvable problem. I listened to Dr. Argel speak at UNO, and he said that this was the unsolvable problem. And the reason is that those amino acids that we're looking at, and this is an important concept. If you want something that's not real technical, and you want to give somebody, an evolutionist, something that'll drive them crazy, and it's been driving Dr. Argel crazy, ask them this question. You see, in living systems, the amino acids that make up proteins, remember, amino acids you just put N to N to N to N in a long order. You can get any one of 20 different varieties to spell out, just like a code, just like a word, just like a sentence, exactly what type of protein it's going to be, depending upon what order you put it in and how many you have. But here's the problem. Amino acids come in 2 varieties, left-handed and right-handed. And the problem